All right, welcome back, everybody. This is
Hey,
Mark, and I'm joined by Glenn. We are here with another update and a recap on the challenge that just happened. So the most recent challenge that finished was called N Buns, and I wrote this challenge, and we're just going to go ahead and jump into it.
yeah,
Glenn, you want to
tell
share
us
any?
more about it.
Yeah, here we go. So this was this is one of those challenges where there's
You wanna font size up?
oh yeah. Basically finding the challenge where easy so we gave there is a lot of function itself. Look for these functions that aren't randomly named and see to reverse engineers. But we can look at this kind of give you an idea of like what it look like. Again, very similar kind of stuff. It's some number of operators that end up making what the graph is. But it looks like a big tree. So zoom, enhance. Uh, you can see.
For a second, I think you're on.
Let's see.
Yeah, as always.
What's going on?
All right, that managed to fix it. Whatever you did.
Are we good?
I seems like keep going.
Okay. Well, so basically what we're looking at here is a giant tree. And so there's some number of functions in the names. And so the first step is sort of we got to talk about because oh, how about a
All right, good luck doing the whole presentation while tabbed in the whole time
tabbed into
to OBS. Is it
oh
getting
okay.
like I don't know, low
I,
priority or something?
I don't know. I don't know. Here, I will try to make my VM smaller and hopefully how's that? Can you hear me now?
All right, keep going.
Okay. So the basic idea here is we just need to do some sort of dynamic analysis. And the great news is that we had a lot of different competitors taking different approaches. The first solve we saw was from mHackeroni, and this was a really fast solve. It was about 33 minutes in, and they just used a pin tool. And now pin tools you normally would compile, and they were gracious enough to share their source with us. But if I can get my clicker to work here, uh, it's a really simple pin tool. It's very short. Again, this is sort of like one of the most basic dynamic analysis passes you could perform. But we got to see it done in a lot of different ways. One of the other really common ways, the most popular way that people did this, over half of the solvers did it using GDB. About half of them used plain GDB scripts, and the other half used Python scripts. This is an example of what one of those plain GDB script approaches looks like. Basically, there's only one problem with the GDB script, which is if you try to set a breakpoint on a function that doesn't exist, GDB will get mad at you. And so the first step that you see, pretty much everybody who did it this way, you'll see that they enumerate the functions. And so
so they like read them all out of the ELF file, and then they can know which ones not to jump to.
Yeah, exactly. So an approach like this, where they're listing out the symbols, and then what they're looking for is this length set split sort of thing. The functions are not randomly named. They have functions like a, or similar for whatever letter. And so what they're doing is that they're finding functions that have that pattern, and then they're just creating a list of them and setting a breakpoint on them. And that way they can do this dynamically for every binary that they receive, because there's going to be 10 rounds that they have to get the binary, do this dynamic analysis, and then respond what the password is. And the password's always in this format of like pass, curly braces, and then some random text in the middle. So there's the basic approach. But some of the more interesting things that we saw, Blue Water here used this script, again, a GDB script, but this one is a GDB Python script. And this was brought in from a third party. So again, working smarter, not harder. I like this approach. Basically, someone else had written a GDB script that could do this sort of thing, and they just used it. But some of the other interesting things we saw a Cheeling approach. I like this one because it's pretty short. Basically, you can see that exact same approach where they're taking the binary, going through symbols, looking for that pattern of the symbol that is mostly just a repeating of one letter. They add it to their list, and then they just hook that address and run the binary. Really simple. I think that this is probably one of the shortest solves. So really great work by Hofhackerai, if I'm saying that right. Some of the other ones we saw Frida in play. So this one's basically just a similar sort of analysis using Frida.
Oh no, is that JavaScript?
Yeah, Frida uses JavaScript. So
oh my goodness.
they're just dropping it in there. And yeah, again, just doing that same sort of thing where they're looking for repeated letters. For shellfish, of course, naturally, what they use. Anger.
Of course, it wouldn't be shellfish if they didn't use anger.
So, and I was proud of this. And the timeout on this was actually pretty generous. It was 10 seconds per binary. And if you did it the way the reference solution did, which was via a plain GDB script, you could solve it in under a second. So 10 seconds was long enough that I thought maybe somebody might do like a symbolic execution, or maybe even like a really fancy static solve. It was open. We got to see an anger solution. So, great reference when that gets posted to see how the anger authors do this stuff.
We're getting a lot of good anger references from this.
You know what? I'm trying. And then this team never stopped exploiting. They shipped a binary, and when I took a look at this binary, it looked like a custom Rust tracer. So, whatever gets the job done. Maybe they'll share their source code, put it up as a gist or something on GitHub. And then the last call out is to SNHT here. I don't know what their deal is, if they've got some sort of like.
No, that's what I call Zoomer style reversing.
Right? But props to them, because despite their Zoomer style reversing, they're using Valgrind. They've got a specific tool called CallGrind, which does do call graph tracing. And that's a great idea for this. And it looks like that all they do is parse the lines out. So I wasn't familiar with the CallGrind format, but it looks like it's just sort of plain text parsable. So that's pretty fantastic. So overall, we got to see a lot of different kinds of solutions for this, which is great. That's exactly what we were looking for. Um, we had a good number of solves. We had 18 total solves,
Pretty good.
8 different sort of tools being used there. Um, and really, it was interesting because within the first hour we had 6 solves, and then the next 12 came in between hours 1 and 3, and there were 0 solves in the final hour. So I don't know if it was probably a hard day, and I'm guessing the fatigue is just getting to people after we've been going on this long. But so I was really pleased to see how this one turned out. Again, not that hard in terms of like figuring out what to do, but seeing people really embracing trying different methods and taking a spin on some other tools besides just the GDB script that was obvious. Though interestingly, at Macaroni, going with the pin tool with the fastest solve. So overall, I thought it was a pretty fun problem. Go ahead and bring us back.
All right.
So we've got another problem just opened up about an hour and 15 minutes ago, and it will run again for the 4 hours. Glenn, you read this problem?
Yep, this is Sokabin. All I will say is I'll read the description for you, and then the competitors can be amused at the reference.
I love
It's
the
just
description.
rose is red, violet is blue, rip is win, stack is move. I was describing this challenge to Rusty at work a couple weeks ago, and he just riffed that entire description off. Like, my man he's smart even at puns.
That's
So
fantastic. I laughed out loud when I read it
yeah,
because
it's a good
I'm
one.
a big fan.
I wish I wrote it. But no, I wrote this challenge, and in about 4 hours, I will see if anyone has solved it. I guess 3 hours to see if people have solved it. No one has solved it yet. And yeah, till then, I hope the competitors enjoy.
Yeah, and just to do a quick recap, that top of the leaderboard, still a lot of movement. Right now we're looking at Super Dice Code with the lead, followed very closely within 15 points. No, 20
Wow, that is
points.
within tiebreaker.
Yeah, is MMM, and so that's like being a little bit slower at Live CTF challenge could cover that ground. Um, Followed by Hoff Hakurai, Shellfish, and Macaroni at number 5. So
Pretty tight
stay.
competition. Well, first and second place switching up a lot, and then after that, like it's a solid 8 or so teams. I guess 7 teams vying for those top spots. And Carl's team that he's enthusiastic about is down at 22. I felt like I just had to mention it. They're trying. They're doing well.
Way to keep up with the storyline. We want to know that
He
underdog.
went to
Maybe
bed,
the
but his spirit will join us from the dreams. I don't know the metaphor there. Anyways,
Anyways, it seems like this is a great example of DEF CON Quals. A lot of good work being done out of there. Thanks for everybody playing. Glenn, anything else before we sign off?
nope. Just happy hacking, and see you in a couple hours.
Yep. See you all in a few hours. Cheers.
See y'all.